Okay, so welcome guys. So today we're actually gonna go through how to find exact values of trigo functions. So I'll go through 8 questions and there's 3 different types. So let's get started. So the first question says that given that A is between 0 and 180 degrees and tangent A is 3/4, we have to find these values. So when A is in between 0 and 180 degrees, we know that this is in the first or second quadrant. But it says that tangent A is 3/4. Now tangent A is positive. If tangent A is positive, using our ASTC rule, that means that A must be in the first quadrant, since tangent A will be negative in the second quadrant. So now we can draw out a diagram to show how tangent A and how angle A will look like. So if let's say this is our diagram, where this here will be angle A, we know that tangent of angle A is 3/4. So tangent is opposite over adjacent, so we know that our opposite will be 3 and our adjacent will be 4. So now to find our hypotenuse using Pythagoras, it will be 5. So now to find cosine A is adjacent over hypotenuse, so it will be 4/5. Sine A is opposite over hypotenuse, so it will be 3/5. And now question C is cotangent A and secant A. So cotangent A is 1/tangent A, and secant A will be 1/cosine A. And since we already know these values, we can plug it in. So tangent A, as given from the question, is 3/4. Cosine A, as we found out, would be 4/5. And then we can multiply, and in the end we will get 5/3. So that's the first question. Now for question 2, it states that this angle is between pi and 3π/2. So actually we can calculate what these are. Pi is 180 degrees and 3π/2 is 270 degrees. And we know that since cosine is like this, it will be in the third quadrant, and it's correct because in the third quadrant your cosine will be negative. So now we can draw out our diagram. So alpha will be in the third quadrant and your reference angle will be this. So I'll just extend this out a bit more. So your cosine is always your adjacent over hypotenuse. So it'll be -7 as the adjacent and 25 as the hypotenuse, because your hypotenuse will always be positive. Now to find our opposite, we'll just use our Pythagoras theorem. So our opposite will be minus square root 25 squared minus 7 squared. So this is minus 24. Now why is there a minus? Because your y value is in the negative region. This distance is in the negative y-axis. Now since we have our triangle, we can use tuakaso for these questions. So A, to find sine x, sine alpha, will be your opposite over hypotenuse. So it'll be minus 24/25. For B, secant is 1/cosine, and the question already gave us cosine, so that's just the reciprocal, so it'll be minus 25/7. And our last value, C, is cotangent. Cotangent alpha will be 1/tangent alpha. And your tangent is opposite over adjacent, so it'll be minus 24 over minus 7. So it's 1 over 24 over 7, and that will be 7 over 24. So that's how you do question 2, part C of question 2. So now we're going to go through question 3, and it says that given that sine 15 degrees is equal to k, express in terms of k these values. So first draw it out. We know that 15 degrees is an acute angle. So we can draw out our diagram as such, where this is 15 degrees. So this is our right angle triangle. Now, sine is opposite over hypotenuse. So you know that your opposite will be k and your hypotenuse will be 1, because this will be k over 1. Right? It gave you that sine will equal to k. So now, to find this side, which is our adjacent, it's using Pythagoras. So it'll be square root k squared minus 1 squared, which is just 1. There we go. So now to find cosine of 75 degrees. 75 degrees is here. So cosine of 75 degrees will be adjacent over hypotenuse. And cosine's adjacent is k, and the hypotenuse is 1. So that will be k. For B is sine 165. Now sine 165 will be equal to sine 15 degrees, which will be also k. This is because if I draw out my another diagram with 165, you'll realize that my reference angle will be 15 degrees. C wants us to find cosine of 195 degrees. So here we'll draw out another diagram where this will be 195 degrees. And we want to find cosine. So this is minus cosine 15 degrees, since this is in the third quadrant. So cosine of 15 degrees will be minus, and cosine of 15 degrees is adjacent over hypotenuse. And here I actually messed it up. This will be 1 squared minus k squared. So it's 1 minus k squared. So that's your C. And then D, tangent minus 15 degrees. You can actually bring out the tangent. You bring out the negative. You have minus tangent 15. So tangent is opposite over adjacent. So it'll be k over square root 1 minus k squared. And this is how you do question 3. Question 4 is similar, it's basically the same thing. So they gave us that cosine 25 degrees is p, and we have to express these values in terms of p. So sine 65 degrees, when we draw it out, this will be your 65 degrees. And we have to find sine of this. Now this is your 65 degrees. Since this is a 90-degree triangle, we know that this will be 25. And we found out that cosine 25 degrees is p. So cosine is adjacent over hypotenuse. So here your adjacent will be 1. Will be p. And your hypotenuse will be 1. Since cosine 25 will be p or p over 1. Now to find this side, it's just this again using Pythagoras theorem. So to find sine of 65 degrees will be opposite over hypotenuse. In this case is P over 1 or P. II is cosine 155 degrees. So you want to draw out our diagram. So cosine 155 degrees is like that. So our reference angle is 25. And in the second quadrant, our cosine will be negative. So we have to take that into account. So cosine 155 degrees will be minus cosine 25 degrees. And we know that cosine 25 degrees is P, so it will be minus P. For III, we want to find sine of 205 degrees. So again, we'll have to draw out our diagram. 205 degrees, our reference angle will be 25 degrees. And here, since we are in the third quadrant, sine will be negative in the third quadrant. So we know that this will be minus sine of 25 degrees. Now sine of 25 degrees, we already had this diagram over here. So sine of this value will be opposite over hypotenuse. And your opposite in this case is square root 1 minus P squared. And your hypotenuse is 1. So be like this. So we can, the divide by 1 is just redundant. So this is your answer. Then we have IV on number 4, where they ask us to find secant of 335 degrees. Now secant is 1 over cosine. So again, we have to draw out the diagram. And again, you realize that your reference angle will be 25. And cosine in the last quadrant is actually positive. So that's nice to know. So this will be 1 over cosine 25. And we know that cosine 25 is P, so this is 1 over P. So that is how you do question 4. Now question 5 onwards is where it gets a bit tricky because we're introducing two angles instead of just one angle. So it states that angle A and B are in the same quadrant such that tangent A is positive and sine B is negative. So for tangent A to be positive and sine B to be negative, these two, A and B, must lie in the third quadrant. Because sine can only be negative in the third and fourth, and tangent can only be positive in the third quadrant. So that's why A and B lie in the third quadrant since the question states so. So now we have to draw two diagrams, not just one, because we have two values. So now we'll draw firstly for A and we'll draw for B. So for A in the third quadrant, this is angle A. And we get that tangent A is 3 over 4. So tangent is opposite over adjacent. So this is 3, this is 4. But since they're in the third quadrant and both are in the negative zone, it's actually minus 3 and minus 4. because they're in the negative x-axis and the negative y-axis. Now to find our hypotenuse is just 5 because of our 3, 4, 5 or our Pythagoras theorem. Then let's do the same thing for B. This will be angle B. This will be our triangle. Now B will be minus 5 over 13, and sine of an angle is opposite over hypotenuse. So opposite is minus 5, hypotenuse is 13, as given by the question. So now we'll have to find this side, which we can find via Pythagoras. So this will be let me calculate that real quick. This will be minus 12. So now we can do these questions. So A, sine minus A, we can bring out the negative. That is minus sine A. Sine A is opposite over hypotenuse, so we minus 3 over 5. But since the minus, there's double minus, it will become positive. B is cosine of minus B, and this actually is just redundant, so it's cosine of B. And cosine of B will be adjacent over hypotenuse. So it'll be minus 12 over 13. For C, they want us to find secant A. Secant A multiplied by cosecant A. So secant A is 1 over cosine. Cosecant A is 1 over sine. Then we have to plug in our values. Actually, we have to find them. So cosine A, if you look at the diagram here, cosine A is always, cosine is adjacent over hypotenuse. So it'll be minus 4 over 5. Sine is opposite over hypotenuse, so it'll be minus 3 over 5. So this will be minus 5 over 4 times minus 5 over 3. This will be 25 over 12. And lastly, D. D is cotangent. Cotangent A, cotangent B. So this will be 1 over tangent A multiplied by 1 over tangent B. So tangent A is given in the question, actually is 3 over 4. Tangent B, we can find it out, opposite over adjacent. So it's minus 5 divided by minus 12. So this is 4 over 3. This is 12 over 5. You'll get 60 over 15. So 48 over 15. And actually we can simplify that further. I did not realize that. So it's actually 16 over 5. So there we go. That is question 5. Question 6 states that tangent A equals minus 5 over 12 and that cosine A and tangent A have opposite signs. So we know that tangent A is negative and cosine A must be positive. So this must be actually in the fourth quadrant, because tangent A is negative in the second and fourth quadrant, and cosine A is positive in the first or fourth quadrant. So now we can draw out our diagram. And your reference angle will be here. So tangent is opposite over adjacent will be minus 5 over 12. So we can find the hypotenuse to be 13. Okay, so now we have to find sine of minus A. Be minus sine A. Sine A is opposite over hypotenuse, so that will be minus 5 over 13. And since it's negative and negative, it will become positive. And B wants us to find cosine of minus A. This is just cosine of A. And cosine of A is 12 over 13. Since it's adjacent over hypotenuse. C wants us to find tangent of minus A, where we can take out the negative. And tangent A was given in the question as minus 5 over 12. So your answer will be 5 over 12. Now D wants us to find tangent of pi over 2 minus A. So where's that actually? So if this is A, your reference angle is here. To find pi over 2 minus A will be this. This is pi over 2. Pi over 2 minus alpha, our reference angle. So to find tangent of that, we have to take into account this. And then, since it's pi over 2 over A, it will be opposite over adjacent from here. So my opposite will be 12. My adjacent will be minus 5. So I'll get minus 12 over 5 as my answer. So that's question 6. So for question 7, it's given two variables. Sine 25 degrees equals k, tangent 25 degrees equals t. So we'll draw out a diagram for 25 degrees. And for the first one, it says that sine 25 equals k. So this will be k, this will be 1, because it's opposite over hypotenuse. And for tangent, it is opposite over adjacent. So tangent actually says t. So this is t. I'll use another color. T. This is 1. But they're not equal, they're different. Okay? So for here, in terms of k, this side will be 1 minus k squared. In terms of t, this side will be t squared plus 1 square rooted. So now we can do these questions. Cosine 25 degrees will be adjacent over hypotenuse. So it'll be this. But then the divide by 1 is redundant. II is cosine 155 degrees. This will equal to cosine 25 degrees minus, if we draw it out, here will be 25. But it's minus because it's in the second quadrant. So cosine of 25 will be the same thing we got above, so 1 minus k squared. We get sine 205. If we draw it out, I know we have to draw a lot of diagrams for these type of questions, but you get used to it. So you get your reference angle to be 25 degrees. But it'll be negative because it's in the third quadrant, and sine in the third quadrant is negative. So minus sine 25 will be minus k. It's given in the question. And lastly, for IV, they want us to find tangent 335 degrees. This will be tangent 25 degrees, but again with a minus because fourth quadrant. Just draw it out. 335 is here. Reference is 25 degrees. But my tangent will be negative because fourth quadrant. So tangent 25, it's given as t. So this is minus t. So there we go. These would be the best answers. Of course, there are other ways to do it. As we can see that cosine 25 degrees will also be that, or in terms of t, since cosine is adjacent over hypotenuse, it could be 1 over square root t squared plus 1. So this can also be minus 1 over square root t squared plus 1. But it doesn't look that nice compared to when we use the k value. So that's why we'll just stick to the k value. And now we're finally on our last question, which is question 8. So for question 8 is our last question. It states that tangent 8 is 3 over 4 in the first quadrant, and tangent b equals k in the second quadrant. Now if you know in the second quadrant, tangent is always negative. So we have found out that k is a negative value, and this is especially important. This is a tricky question in this regard. So A is sine. To find sine A, we first draw the diagram for angle A. So it'll be like that. And if tangent A is 3 over 4, we know it's opposite over adjacent. So this will be 3, this will be 4. And your hypotenuse will be 5 based on Pythagoras. So sine A will be 3 over 5 because of opposite over hypotenuse. Now to draw the B is where we have to be a bit careful. So I'll just draw it out first. So this will be an angle B in the second quadrant, and we'll draw out our triangle, right? Now, your tangent here is K, where K is negative. So it won't be k and 1. It won't be k and 1 because this length here cannot be negative. This length is actually positive. And this length here is actually negative because it's in the negative x-axis. So actually, we put these values down as minus k and minus 1. Because minus k over minus 1 will still give you k, but minus k here is positive, which is correct, and minus 1 here is negative. So this is where the drawing of the diagram is a bit different. It's not just k over 1, it's actually minus k over minus 1. So after we've done that, the hypotenuse through Pythagoras theorem is just k squared plus 1 square root the whole thing. So now b. Cosine of b is adjacent over hypotenuse. So it's minus 1 over square root k squared plus 1. For tangent, 180 degrees minus b, it's basically this angle over here. But tangent 180 degrees minus b, this will be acute, and tangent of an acute angle is always positive. So as such, it will be minus k over minus 1 in terms of your regular tangent, but this will give you a negative value, right? So actually your answer is minus k. And this also follows the formula that tangent 180 degrees minus b will be minus tangent b. So we're using this formula if you can identify it, or we're using some thinking skills. Question 8 is especially tricky because you have to take note of these special circumstances where both values are negative to give a positive. So these are your 8 questions on finding exact values for trigo functions. This is a very commonly tested question in the O-levels or in any kind of paper for AMath trigonometry. So it's good to know how to solve these, and I hope this video was helpful.